We're to part 7 of the review of 8, so we're almost done. Trig review. The first question asks us, what quadrant the angle 155 degrees would lie in? So what quadrant would 155 lie in? So we need to figure that out. Well, I've drawn it here for you. We've got 0, 90, 180, whoop, didn't mean to move it, 270, and then back around to 360, and then I've got the quadrants labeled with blue Roman numerals. Well, 155 degrees would fall between 90 and 180. So just a rough guess, it would be about there, which shows it would be in quadrant 2. So if you want, you should probably sketch this for yourself whenever the exam comes, so you remember that it's 0, 90, 180, 270, and then back around to 360. And the quadrants are labeled in blue as you see there. Okay, now 2 through 5, I'll just tell you the answers. I'm going to assume you know them. 2 is acute, 3 is straight, 4 is right, and 5 is obtuse. Now moving on to number 6, they ask us to graph negative 100 degrees. So we're doing negatives, so we have 0 degrees, then we have to go the opposite direction normally would, negative 90, negative 180, negative 270, and then back around to negative 360. So negative 100 is going to fall between negative 90 and negative 180, probably about here. So when you draw it, remember to always draw this part right here, which is your starting point, and then this part is your ending point, and you draw an arrow showing which direction you're going. Clockwise is negative, counterclockwise is positive. So similar here with number 40, we have positive ones, so we'll do 0, 90, 180, 270, back around to 360. 40 falls between 0 and 90, so it would go here. Don't forget to draw your starting point and your arrow showing your direction. In number 8, to convert from degrees to radians, you must multiply by pi over 180. So I get this, and I get 240 pi over 180, but I need to reduce that, so I can let the calculator do that for me if I want. 240 over 180, and then I can tell it to make that a fraction for me. So it's 4/3, which means I have 4 pi over 3. Now for number 9, we're converting radians to degrees. So instead of doing pi over 180, we do 180 over pi. So whichever one you want, that needs to go on top. We want degrees, that's why 180 degrees is on top. In number 8, we wanted radians, that's why pi radians was on top. So here in number 9, the pi's cancel out, leaving you negative 180 over 6, which leaves you negative 30 degrees. In number 10, we have to find sine, cosine, and tangent, given that theta is right there in that triangle. Okay, sine is opposite over hypotenuse. So right now, this would be my opposite, this would be my hypotenuse, and this is my adjacent. I don't know the hypotenuse at the moment. I have to figure it out using the Pythagorean theorem. So I use a squared plus b squared equals c squared, and I get 9 plus 16 equals c squared. So 25 equals c squared, or 5 equals c. So now I know the hypotenuse. And sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So remember, soka toa, or some old hippie caught another hippie tripping on acid. That's how you can remember what sine, cosine, and tangent stand for. Alright, so here in number 11, we're not given a picture, so I drew a triangle, and I'm just going to choose to put theta here. So sine is opposite over hypotenuse. Well, this would be my opposite, and this would be my hypotenuse. So sine is 8 over 17, so it's 8 and 17 go there. So to figure out this third side, I again have to use the Pythagorean theorem. But this time I'm solving for b squared, because this always has to be the hypotenuse. And that will turn out to be 15. So then the cosine is adjacent, which is 15, over hypotenuse, which is 17. Tangent is opposite over adjacent. Alright, the next few are in the calculator, so let me pull that up for us. 12. Make sure you're in degree mode. My calculator is. So I just type in sine of 46. There it is, 0.719. Tangent, 34. There it is, 0.674. Now the next part are not in degrees. There's no degree signs there. Okay, so that was, let's see, number 12 and 13. Moving on to 14, like I was saying, sorry for the interruption there, we have no degree signs, which means we have to use the Radian mode. So we go to Mode, go down to Radian, highlight that, and then we do sine of 2 pi over 5. You get 0.95, and then cosine of 2 pi is 1. So that's our answers for 12 through 15. Now for 16, notice we're trying to solve for the angle. 12, 13, 14, and 15, we had the angle. We were trying to find the sine of it, or the tangent of it, or the cosine of it. Here we know what the sine is, we just don't know what the angle we're taking is. So that is when you use the second sine, or the sine inverse, or sine to the -1. So you can actually do this one in either mode, but I'd prefer us to be back in degree. So I'm going to do it in degree mode, and then do second sine of 0.5474. That gives us 33.18 degrees, or 19 degrees, and then second tangent of 23.0307. We get 87.51 degrees. Now we're ready for 18. So solve for x. So we have the angle 37 degrees. This is our pivot point. This is our focus. Now we have the opposite side and we have the adjacent side. The trig function that deals with opposite and adjacent is tangent. So we do tangent of 37 degrees is equal to opposite over adjacent. Now we're trying to solve for x, so we multiply both sides by 250. And we can just plug in our calculators now. 250 times tangent of 37 degrees. We get 188.39 for our answer. Number 19, again, the angle is the pivotal point here. We have our opposite side and we have our hypotenuse. So that is sine. So we do sine of 23 degrees is equal to the opposite, 16, over the hypotenuse, x. This time, x is on the bottom. We have to get it out of there, so we need to multiply both sides by x. So we have x times sine of 23 degrees equals 16. Divide both sides by sine of 23. We get 16 over the sine of 23 degrees. And you get 40.95 degrees. Number 20, find the amplitude and period of the function. Okay, in general, these functions are of this form. The amplitude is the a. It's the number out in front of sine or cosine. It works both ways. So, it's the absolute value of that number. So for number 20 here, the amplitude is 4. It's its absolute value. And for number 21, the amplitude is 1/2 because it's the number out front, or the absolute value of the number out front. Now the period, you have to use a little more math. It's 2 pi over b. So the period is equal to 2 pi divided by your b, and b is the number in front of x. So our period for number 20 is 2 pi over 5, and our period for number 21 is 2 pi over 2 pi, which is 1. So again, I just took my b and put it underneath 2 pi. Okay, in 22, they want us to graph it. Okay, so again, we see here the amplitude is 3. The period is going to be 2 pi over 2, because we do 2 pi over b. So I can go as high as 3 and as low as -3, because that's my amplitude, 3. My period is pi. Sorry, if I reduce this, I get pi. 2 pi over 2 is just pi. So that means my farthest out point is pi. So I'm going to go ahead and draw this. Cosine starts on top, goes down, then back up. My mid from pi is pi over 2. Mid from that is pi over 4. Mid between these two is 3 pi over 4. So if you notice, if you take your period, which is pi, and divide by 4, you get pi over 4. And we're going up by pi over 4 every time. 1 pi over 4, pi over 2, 3 pi over 4, pi. Sorry, I think I just rewrote the same one there. This should be negative 4 sine of pi x. So that's our amplitude, 4. So I know I can go up to 4 or down to negative 4. My period is going to be 2 pi over pi, because I have to take this number and put it under 2 pi. So that means my period is 2. Now sine starts at the origin, but since I have negative sine, instead of usually going up like I normally would, I have to go down, up, down. So then a quarter of 2, or if you divide 2 by 4, you get 1/2, so you go up by 1/2 each time. And that would be your graph. Okay, in 24 we have the normal stuff. This is our amplitude. Our period is 2 pi over 2, so that's pi. But we also have a horizontal and a vertical shift. Horizontal shifts always involve the x, so it's going to happen inside this parentheses. We call this letter our C and this letter our D. The horizontal shift is found by doing C over B. And since it's a minus, that is a shift right. So inside, minus is right, plus is left. Outside, plus is up, minus is down. And it's just that number, so we go up 4. So up 4 and right pi over 2. So horizontal shifts are inside, minus right, plus left, and you do C over B. The things outside, plus is up, minus is down, and it's just that actual number. Okay, now these are law of sines, cosines, and just law of sines and cosines. Getting ahead of myself, or getting carried away. These are again on your formula sheet down below. So the law of sines is right here for you. Don't worry about memorizing it, just make sure you know how to use it. Sine A over A, sine B over B, and sine C over C. Sorry, wrong one. There we go. So I need to do sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. Okay, so the easiest thing to do is to go ahead and figure out side B right here, because all I have to do is cross multiply these pair right here, or this pair right here, and I get B times sine of 44 degrees equals 12 times sine of 25 degrees. So I get 12 sine of 25 over sine 44. And you get 7.3 for side B. So let's fill that in, 7.3. Okay, now we're going to have to figure out something about C here. Well, if you can remember, a triangle adds up to 180 degrees. So that means if you do 180 minus 44 minus 25, you can get the third angle, which is going to be 111 degrees. So now I can cross multiply with this one. I'm going to choose this one and this one to cross multiply with, just because it'll be more exact, because I had to round to get that 7.3 number. So I'll get 12 times sine of 111 equals C times sine of 44 degrees. So just divide both sides by sine of 44. Plug all that mess in your calculator, and you should get C equals 16.13. Same deal, law of sines, and we already know that we can find the third angle by just doing 180 minus these two things. So let's just go ahead and plug in the fact this will be 44 degrees. Again, I get that by doing 180 minus 82 minus 54. So I get sine of angle A over A equals sine of angle B over side B equals sine of angle C over side C. And then I simply cross multiply. So I'll cross multiply these two. Make sure you're in degree mode. You should get B equals 18.63. And then it would be best to cross multiply these two next, and you'll get C equals 22.81. And finally 27. The way you know you cannot use the law of sines is if you don't have any pairs. Now let me back up and show you what I mean. What we had originally in number 25 was angle A, angle B, and side A. So we had a pair here. We had angle A and its corresponding side. So the fact that we had that pair meant we could use the law of sines. Okay, here we had this originally. So we didn't have the pair explicitly, but since we had two angles, we could find this third angle, and then we had a pair again. Looking here at number 27, though, we have no pair. We have side B, but not its angle. We have side A, but not its angle. We have angle C, but not its side. And there's no way we can get a pair just by doing 180 minus the angles or anything like that, because we only have one angle. So that means we have to use the law of cosines. Now if you look here, there are three versions of the law of cosines. A squared equals, B squared equals, and C squared equals. You can tell which one you want by looking at the angle. We have in ours angle C. So we want to use that third one, which is C squared equals A squared plus B squared minus 2AB times cosine of angle C. And we can plug all that in. We get 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 42 degrees. And if you plug all that in your calculator, that will give you C squared. So please remember to take the square root of that answer to get that C equals 4.69. Okay, now the safest thing to do is to use law of cosines again. You can use law of sines at this point, but you have to do things in a certain order, so it's simpler to just use law of cosines the rest of the way through, really just one more time. So we can pick either to find angle A or angle B. I'll just pick angle A. So that means I need to use the equation A squared equals B squared plus C squared minus 2BC cosine of angle A. So if I plug all this mess in, I get 5 squared equals 4.69 squared plus 7 squared minus 2, 4.69 times 7 times the cosine of angle A, which I don't know. So I'm going to get 25 equals, then I'm going to do 4.69 squared plus 7 squared. And I get 70 we'll just call it 71. Minus 2 times 4.69 times 7. So we get 65.66 cosine of A. So then we subtract 71 from both sides. Let's see. Negative, getting tired. Negative 46 equals negative 65.66 cosine A. So we divide both sides by negative 65.66. That gives us 0.700 equals cosine of A. So that's when we have to solve for the angle. So you have to use the second cosine of that number. Remember, you can just hit answer to put in that thing for you. So you get 45.5 degrees for angle A. And at that point, I would just do 180 minus those two to get that this is 92.5 degrees. So you can just do 180 minus 42 minus 45.5. I would be sure to practice law of sines and cosines. They were very common on the exam last time around.